Hi and welcome to a new video here on my channel. As you can judge by the title, this video is about GIGABYTE. So Tom Logan from OC3D, he's a YouTuber from the UK, maybe check out his channel. He's doing a lot of very good and in-depth videos, mainly mainboard reviews as well. So check out his YouTube channel. Yeah, he released a video about the GIGABYTE C370 Ultra Gaming 2.0. So just as a background info, he also made a video about version 1.0 several months ago where he found out that there are a lot of memory issues, like memory clocks would drop down between the boots, and then he also experienced the VRM temperature to be way too high. So he worked closely together with GIGABYTE, gave them a lot of feedback so they could improve all those issues for version 2.0. So obviously he also tested version 2.0 and his conclusion is that he cannot recommend that you buy this board basically because the issues are still kind of there. The VRM is still way too hot. I think he had 123 degrees Celsius under load while the CPU was overclocked. So most of you probably know my VRM X299 disaster video where I brought this whole thing into the public, where I said that basically all the X299 entrance boards, even though they're quite expensive, they didn't have sufficient cooling on the VRMs. The VRMs themselves were actually quite nice, but the VRM cooling was just not sufficient for very strong overclock. And the issue I had personally with this is that most of the manufacturers were still advertising their boards with very strong cooling and perfect for overclocking, while they were simply not that good. Now the question is, at which point is it really an issue that a board has like VRM issues, like the VRM is getting too warm? So for example, I made the C370 Battle of the Cheap video several months ago where I took basically the cheapest boards from each manufacturer, tested them with like different memory clocks and tested CPU overclocking just to check how high can you push your CPU, how high can you push your memory on the cheapest boards, which was quite interesting. So even like a 110 euro motherboard was able to clock like 4.9, some of them like 5 gigahertz. And I think from what I remember correctly, 3600 megahertz on the memory worked on most, I think most of the boards. So actually, quite decent boards for the price. Now the C370 Ultra Gaming 2.0 is around 160 euro, which is a lot higher price than what I tested in the Battle of the Cheap. So yeah, the question is, at which point do you expect that your board can handle basically everything, can handle strong overclocks, can handle high memory clocks? The interesting part is if you go to the GIGABYTE website and just check for the features of the C370 Ultra Gaming, GIGABYTE is not advertising anything with overclocking. I think if you just search the page, there is not a single time a mention of the word overclocking. So personally, from my point of view, I cannot really bash on them for not delivering like proper VRMs or proper VRM cooling because they're basically not advertising for it. So it's kind of hard to tell at which point you can expect a board to run really smooth. On the other hand, of course, the manufacturers should know by now that all the reviews are also testing this VRM thing, so they should maybe do the same testing internally and see if they might have this issue. So I'm not saying it's too smart to release a board that has those issues. I'm not going to test the C370 Ultra Gaming 2.0 myself personally because I'm pretty sure I would have exactly the same result as Tom Logan had, but I asked myself the question, what happens if we take the most expensive board from GIGABYTE with the C370 chipset that's currently on the market, and that's the Aros Gaming 7, which I have in my hand here. And personally, I mean, the first impression of this board is really solid. It looks extremely nice. I would even say that it's like my top three of the boards I like the most, C370 look-wise, but on this channel, it's not about the looks, it's about functionality. So we will test how good you can push CPU and memory on this board, if the VRM is sufficient or not. Looking at the VRM, we have an 8+2 phase design, so we have 8 phases for the CPU and 2 phases for the iGPU. I also have to say that the 8 phases for the CPU are doubled, so the VRM controller actually only has an output of 4 phases, and the 4 phases get doubled, which still helps to spread all the heat across the MOSFETs. So that's nice. And actually, looking at the power stages on this board, I recognized them. They should be Interseal something, and from what I remember correctly, they are the same as on X299 Taichi XE from ASRock, and they should also be the same as on the EVGA X299 Dark. So just looking at the VRM components, I have high expectations, I have to say that. I mean, you can never know how good the VRM heatsink is going to be, because I mean the cover is hiding most of the heatsink itself. Then we don't know how good is the surface area for dissipating the heat, but that's what we will test in this video. So I will set up this mainboard here on my table and I will push CPU and memory to the max. I have a G.Skill Trident Z RGB memory kit with 4266 MHz, so that should be plenty of megahertz for the memory. And also this CPU is a pre-tested CPU for myself, pre-tested at 5.2 GHz. So yeah, let's see how high we can push CPU and memory. So I'm back testing the Aros Gaming 7. Actually spent almost 24 hours with this board now, testing memory settings, CPU settings and all this kind of stuff. But before we will talk over the results, we will just go to the BIOS first. If you go to System, you can see that I'm using BIOS version F6, which was the latest I could find on the GIGABYTE website. If we go to MIT, I will just quickly show you how I overclocked this board for the latest or for my last test. So advanced frequency settings, CPU clock ratio, I set it to 52 to push the CPU to 5.2. XMP, so extreme memory profile, I set it to profile 1, which on this memory sticks is 4266 MHz. And I had to lower it to 4200, so 42, which is still really good. So yeah, a lot of boards have issues with anything above 4000 or 4133. So being able to boot at 4200 from my point of view is more than enough, because personally I would not spend the money for a memory kit like this. Like 4266 or above, in my eyes, is just a waste of money. Rather spend that money and get more memory, so get more capacity, or invest in a better CPU, invest in a better cooler, invest in a better VGA or whatever. But only if you have nothing else to invest in, then you can maybe get a memory kit like this. But from my point of view, yeah, rather get like 3866 or 3600. That should be more than fine. So advanced CPU core settings, again, CPU clock ratio, it's the same setting as in the page before, so set to 52. AVX offset to 3, so it lowers the CPU clock ratio to 49 if we're running AVX load like AVX Prime. Uncore ratio is currently set to 44. I also tried like 48 or 49 for a test yesterday. It worked absolutely fine. I just lowered it to 44 again because I had to align the power consumption. So what's also very important in the GIGABYTE BIOS is that you have to disable the Intel Turbo Boost technology, because otherwise you will have some kind of power limitations and stuff. It's a lot different from the ASUS BIOS. So in an ASUS BIOS, you have to enable turbo mode. Otherwise, you are not able to clock the CPU above the turbo ratio. So that's completely different from GIGABYTE. So on GIGABYTE, always disable turbo. On ASUS, always leave it active. Then we go to advanced voltage settings, advanced power settings, and then you have CPU vCore load line calibration. So you have a lot of different settings, starting from auto, standard, low, medium, high, turbo, extreme. I tested all of them. Basically started with low, medium. The voltage drop is a lot too high, so it's like, even on medium, I think it was like 80 millivolt voltage drop. On high, it was still like 40 millivolt. On turbo, it was like 20 millivolts. So I ended up using turbo mode for load line calibration for my OC setting. Then go to CPU core voltage control, and as you can see, I applied 1.4 volt here. Obviously that's too much, but that's what I used for my last test, where I had to push the power consumption to the maximum for the VRM testing. Typically you would use something like 1.3, 1.35 in this setting. And DRAM voltage control, I set the memory voltage 1.36, which worked absolutely fine. So just judging from the BIOS, just talking about the BIOS, from my point of view, everything worked smoothly. I mean, I could just go to the BIOS, push the CPU to 5.2 within, I don't know, 3 minutes, and setting the XMP profile. Well, XMP didn't work at 4266, but it worked at 4200, which is still pretty good, because most boards are not able to boot at like 4266. So once you're done with this, just hit F10, apply the settings, and then we go to Windows quickly. So we're in Windows, and I already opened the most important tools. So you can see I opened CPU-Z. If you right click, you can see all the cores are running at 5.2. Core voltage is fluctuating a little bit from 1.39 to 1.40, which is absolutely fine. If we go to mainboard, you can see I'm using BIOS version F6. Memory is running at 4200 megahertz, as I said before. Cache frequency is currently at 4.4 gigahertz. I opened core temp to show you that the power consumption reading has to be too low. Like we can just do a Cinebench run, Cinebench R15. You can see the temperature, yeah, it's getting quite warm, which is fine. It's 1.4 volt and 5.2 gigahertz, so temperature should be okay. But you can see power consumption is reading 140 watt here, which is definitely too low. So if I check what the system is pulling from the socket, it's around 250, 260 watt during Cinebench, and you can estimate that the basic components of the system shouldn't pull more than 40 or 50 watt. I mean, it's an R7 250 GPU, and the GPU in idle is not pulling more probably than like 15 or 20 watt maybe. And then we have the water cooling unit, the fans and all of this stuff, but really it shouldn't be more than like 40 or 50 watts. So I assume that CPU power consumption in this case should be around 200, 210, maybe even 220 watt. So when I did the power consumption testing for the VRM, I will refer to the total system power consumption because it should be more reliable than what we can see in core temp. I also opened hardware info, so in case you have this board and you want to check your VRM temperature, you have to scroll down a little bit until you can see temperature 5 here. It also depends on your hardware info version, I think. So I used an older version before and I could not read it out, so used 5.44, which is still not the latest one, I think. But temperature 5 is for sure the VRM temperature in this case. We can also do a Cinebench run. You can see it's only slowly ramping up, but it's like 50 degrees Celsius currently, which is totally fine. If we go to CPU, you can see the core voltage is also quite stable, 1.39 volt. So load line calibration also works fine using the turbo setting. So as you could see, I could push the CPU to 5.2 gigahertz without any issues. Load line calibration also worked fine on turbo. So you could even use extreme if you want to, but then I guess you would get a quite significant overshoot in vCore under load. So I would not recommend to use extreme load line calibration. Also memory clocked pretty much fine for me. So 4266 did not work, but 4200 worked, which is in my opinion still fine, because personally I would always recommend like 3866 or even just 3600. Just save the money. Instead of buying a very expensive memory kit, just get like better SSD, get more memory, get a better CPU, get a better GPU. It's all worth more than investing into like 4266 memory clocks. So what about the VRMs? Let's go over the test results. The first test I did was on stock. So we're talking about total system power consumption, which was in this case 155 watt. And the maximum VRM temperature recorded was 66 degrees Celsius, which is totally fine. I'm also talking about an open test bench, right? So the system is just sitting here on the table. There is no airflow on the VRMs, no airflow on the heatsink, which is typically the way I test, because this is also the condition you can have in a very bad or non-ventilated case. Of course, if you have a case that has very good airflow, it's good for you because you will have lower VRM temperatures, but then there are also cases that have very bad ventilation that also will have the hot air coming out from the GPU that also might go up and also have an influence on the VRM. So that's why I typically test open on the table without any airflow, just to see how good the heatsink is. So the second test was 5 gigahertz and I was pulling 225 watt from the socket, which resulted in a maximum VRM temperature of 91 degrees Celsius. Third test 5.1 with 237 watt power consumption, resulting in 93 degrees Celsius VRM temperature, and the maximum I could pull was 250 watt, which was a setting with 5.2 gigahertz on the CPU and I think 4.8 gigahertz on the cache, which then resulted in 96 degrees Celsius VRM temperature. So as you can see, I could not get this board to throttle, and 96 degrees Celsius, like 5.2 with high cache, with 1.4 volt, no airflow on the VRM. That's pretty much the worst case scenario, also running Prime 95, of course. So from what I can tell, VRM components are very good. VRM heatsink is obviously not the best. I mean, it could be colder, but 96 degrees Celsius under this condition, I would say, is fine. So to answer the title of the video, is Gigabyte really that bad? No, they're not. It just depends what you're looking for. It depends what the product was designed for. So if you're going to buy a 120 euro motherboard that's designed for gaming and they're specifically saying it's not made for overclocking, don't expect it to be an overclocking hero. But this board actually works quite fine. I mean, it's a lot more expensive, obviously, but from what I can tell, all the BIOS functions, CPU was clocked fine, memory was clocking fine, VRM temperatures are fine. So yeah, I can absolutely recommend this board. I have no issues with it. I would still say that the Ultra Gaming 2.0 is not the best board if you want to do overclocking. I'm still with Tom Logan there, but if you're looking for a high-end overclocking board and you want to get Gigabyte, get this board. I hope you enjoyed this video. See you soon.